Hey, what's up guys, welcome to my channel. In the edition of this video, we'll be creating machine learning model for our hash price prediction data set. We're going over different machine learning algorithms such as linear regression and also regularization method, which are your Lasso. Guys, don't forget to subscribe to my channel so you'll be the first to notify when I upload new data science and machine learning videos. Okay guys, let's go. Okay, the first stage which we are going to be going over, we're going to be importing our required libraries and importing required libraries. Okay, libraries. Okay, the library which we are going to be importing, we're going to be importing chunk test loop one sqn dot order selection. Want to import train test needs. Okay, also going to import for preprocessing. Also go to importing a standard scalar, scaling dot processing. Import standard scalar. Okay, and the last, I think the beginning is our score to evaluate our machine learning model. Scaling dot actually not model, metrics provided by scaling. But okay, and let me run this now. So guys, this is a continuation of our first video which we created before about the processing of our data set. I've already gone through the major phase of processing of our data set. This was the code we wrote. So the code we wrote in our former tutorial. Don't worry, if you are going to check it out, I will place a link in the description below so you can go check it out before continuing this video. Okay. Well, if you have processing data, you can just join me in as we create machine learning models for our data set. All what we are doing now, we're just creating machine learning models for our hash prediction data set. Okay guys, let's continue. The next thing which we are going to be doing, we're going to be splitting of our data set. Okay. Before splitting our data set, we have to scale our data set. Okay, we have to scale our data set so our data set will be in a range of values. We don't want a situation where we have some values being in maybe 2 and others being 200 or 100. We want to scale our data set to make them be in same range. Okay, to do that, I'm going to call my scalar constant that scalar. Okay. Then I'm going to cross with my scalar which I created to fit transform. Going to change transform. Okay. Oh, what's happening to me? I have not define my x and y variables, so I can't actually scale it. So I'm going to call my x should be equal to, which are my independent variables, should be equal to my df.drop. I want to drop my price, which is my dependent variable, and as one get column as this. Then we also define my y to be equal to y. Okay, when I run this now, I will define my better than my independent variable. Now I just transform my independent variables. I'm going to transform x. Okay. Let me run this now. Okay, here you can see, let me store it in a variable called scaled. Scaled. Okay, let me run this now. Okay, I already scaled my values, which you saw before. See here, they have been standardized. What this standard scalar simply do is that it subtracts your value, each of your value from the from the column mean and divide it by the standard deviation. Well, that's what standard scalar simply do. Okay, the next step we shall do now, we're going to be splitting our data set into train and test, S train and S test. Okay, I'm going to split our data set, go Y train and Y test. Okay, I'm going to call this one. This one package I imported earlier, my train test to split my data set. Test split. I was X Y. I'm going to set my train size. I want to be using 80% of our data set for training, 0.8. Automatically, we set our test size to be 0.2. Okay, so I'm going to now set my random state. I'm going to set to 42, which is the answer of the universe. I'm going to set to 42 now. I'm going to do this now and check my S train shape X test dot shape. Like this, you can see here, this 80% of our data is 404 rows, while 20% of our data is 102 rows. Okay, we have splitted our data set and also we have skewed our data set. The next step is now modeling. We are going to create machine learning models. First machine learning model which we are going to be using is going to be linear regression. Since it's a regression problem, we are actually determining the value of the house, which is the price of the house. So I'm going to call this linear regression. Okay. To perform this linear regression, I want to import my linear regression from scale to linear model. Say from scale dot linear model to import linear regression. Okay, perform a linear regression. I'm going to initialize and call this model 1 linear regression. Okay, and we're going to fit our model, which is our linear regression on model 1 on model 1 dot fit. We're going to be fitting it on the train data so we can make prediction on our test weight. What did I do? This is supposed to be my S scaled. Okay, it's supposed to be S scaled because I scaled this my data set. What this did before, it just splitted this my unscaled data set, which is just my that my value which has not been scaled. So I'm going to split my scaled data set. Okay, I already scaled it now. This is the scaled version. Okay, I will fit S train on my Y train. Okay, my Y train data set. Let me run this now. I'm going to train it. Okay, it has already been trained, it has already been fitted. So I'm going to make predictions with it. To make predictions, I'm going to store it in widespread. I'm going to say model 1 dot predict. I want to predict using this one S test features of variable. I have to predict the price of the house. Okay, let me run this now and let me call my widespread. Okay, let's check this. Okay, you can see these are the predictions of the house which he predicted. So actually, let me check the accuracy, the hour score value. Let me check the score. We check the score. I'm going to call my hour score which I imported earlier. Some evaluation metrics. I'm going to accept my Y test, which is my actual predictions, a widespread, which is my predicted values. Okay, and we want this. What is this? Oh, so TBA lowercase. That's what we want this now. CMI. The linear regression is having an accuracy of 64.6%. Okay, it's performing quite well. So what I'm going to do next, let me actually check my predictions and my actual value. Okay, let me create a Pandas DataFrame to view our first 15 values of my pred and my actual values. Okay, to do that, I'm going to import pandas as PD. Then I'm going to create my data frame of first 15 values. I'm going to call PD dot DataFrame. And for this upon to learn the first 15 values, then my put them. Let me run this now and see my predictions and my actual values. You can see here, my actual value was 23. My model predicted 30. My actual value was 32. My model actually got this one 32. My actual value was 13. My model predicted 17. So just check out all these values and check how our model misplaced some of them. And see my model have a very bad prediction here. Just imagine 7 and experimenting -5. So that's how I use linear regression. So our next modeling machine learning algorithm which we are going to be going over is regularization method. Okay, make you my heading. What is alright? Regression method, which are your ridge and your lasso. This your ridge and lasso. They are regularization technique which are used in linear regression. They are shrinkage method and they simply shrink the coefficient or importance of values that is in our independent variables. Okay, the main difference between my ridge and my lasso is that one my lasso is more straight. Ridge is less straight in the sense that my ridge actually reduces the coefficient of unimportant features or features that don't have high correlation with my parent variable, such which is my price, to a lesser number but not actually 0. While my lasso actually reduces my unimportant features or features that don't have high correlation with my dependent variable, in this case my price, to most times 0, thereby having no contribution when my model is fitting. Okay, so to do this, I'm going to import ridge and lasso from sklearn model. So I'm going to say from sklearn dot linear model, and will import my ridge and lasso. You may want this now. Okay, I've already imported them now. So I'm going to first of all begin over my ridge. So I'm going to call this model 2, should be equal to ridge. And by the way, this my ridge and lasso accept just one parameter, which is called the alpha. It is alpha that determines the shrinkage method of my regularization method, which is my ridge and lasso. So a higher alpha value will cause my regularization method, in this case my ridge, to shrink the coefficient of the features, while a lower alpha value because my ridge regression to be less straight. Okay, I'm going to set my alpha now. I'm going to set to be 0.5. Okay, I'm use 0.5 first. Let me run this. Then let me fit my model 2.fit. And fit my X train, my Y train. Let me run this now. Okay, I've fitted it. So let me make predictions with it. The 2.predict X just let me store it in a variable Y. Let me just call this one, since we already have white period already. It's white period 1. Let me run this now. Okay, let me check my Y red 1. Okay, so this is my prediction which my regression method got. Let me check the our score. Let me see if it's higher than one of linear regression. So got this. Okay, got this test. Actually it's going to be my white test and my white bread. That's my white bread. So I'm gonna change it. Where this okay. And see I'm having an accuracy of 64.6, same as before. Okay. Actually, as I said before, this my ridge and lasso regression. It actually shrinks my coefficient of my values. So I can actually check my coefficient now using my go with 2. If me explain, me show you what I'm trying to explain. And see here, these are my coefficients. See, these are my coefficients of the values. The degree of correlation which each of my features of variable have with my dependent feature, which is the price. See here, it has shrunk most of them. And if I increase the alpha value, it's going to keep shrinking this my coefficient. So what I'm going to do now, we don't actually know the right, you can't actually determine the right alpha value for your ridge regression or lasso. So what we're going to do now, we're going to use a method called cross validation to determine the perfect alpha value, okay, in a range of values. So to do that, I'm going to import cross validation from sklearn to importing validation curve to import validation curve. Okay, let me do this now. I already imported it now. So what I'm going to do next now, I'm going to send the value in with train scores. Scores. No, change score. I'm going to just okay. Validation of okay. The model which I want to be using will be our ridge with our ridge regression, then strong control. Then I'm going to come down here. I'm going to grab my power name. Power name should be equal to my alpha. We're changing our alpha. We're testing our alpha value. Then my power range, I'm going to set it to okay. After all, we need a range of values. So to get a range of values, we are going to be using NumPy. Let me just create a new happening. Let me create a new row here. So we are going to be needing a range of values. So I'm going to import. I'm going to say from okay. Actually, I'm going to import NumPy as import NumPy in numerical package as np. Okay, let me add more. Yeah, okay. Let me run this now. I want to use my NumPy package to create a value ranging from 10 raised to the power of -2 to 10 raised to the power of 8. Okay, to do that, I'm going to call on more studies in power ranges. Okay, I'm going to call np.logspace the log space, okay, from -2, okay, raised to the power of 8. I'm going to be needing about, let me use about 200, or going to be 200 values ranging from 200 random value ranging from -2 to 8. So let me run this and let me and then it's okay. Yeah, you can see our random values from our random 200 value ranging from -2 to 8. So let me just do this. Okay, to do this now, I'm not going to list my param from this here. Okay, I think I can. Well, look on this now. It's going to take longer time to fit now because it's fitting on it is testing on about 200 values. It's done. So let me show you guys my test scores. We're only interested in our test scores. And by the way, what I'll tell you guys is a 5-fold validation curve. Is here we're having 5 values per each score we got. So what we're going to do now, we're going to find the mean of each of these values for each of our param range we used. Okay, to do that, on this we go and just here I'm gonna call test mean. Find the mean of those our test scores. Report and test scores as is now. Okay, let me run this now. Okay, then we're going to check for the point or the value in which our test score have the highest test mean. Okay, to do that, I'm going to click OK. I'm going to go test mean, which I got just one dot max. Okay, you can see here we're having a test score of 71% here. Okay, now I want to check for the param range or the value in which our test score got this value. Okay, to do that, I'm going to click on my dot here. Right. Test mean go to and test mean dot mass. Okay, let me watch this now. You can see here it was at index 60. So to get the value that is at this is my index 60, I'm going to simply call my param ranges which I created before. Param ranges index 60. Let me want this one. Okay, you can see here it got this my highest test score at the value of 10.25. Okay, let me actually just use the value. Let me use the value now. I'll change this my alpha value. I'll change to 10.25. Okay. Let me run this again. I run this and then check my score. Okay. Actually, there's no difference. What's happening? What is happening here? Okay, it seems we're using this whiteboard which we used for our linear regression. So let me use my whiteboard one which I created. Okay, let me run this again. Okay, yeah, you can see at least it's improved by about 0.004%. Okay, so we're on the right step. So what I want you guys to do for me now, I want you guys to implement the same strategy which we did for this my reach. Same step, just replace this my range with my lasso. Follow same step I followed, fit it, check for position and check for our score. And also I want you guys to use this validation curve to check for the perfect or the best value for your lasso equation. Well guys, thanks for watching. If you are interested in more data science videos and machine learning projects like this, don't forget to subscribe to my channel. See you in my next video.